Hi there, this is Dr. Embody, and this is for CSE 231. I like to talk a little bit about each project, help you get started on it. This first one is inspired by one of the favorite family activities, which is to go wilderness canoe camping. And one of the things that you do is you paddle across a lake and you portage, carry your canoe to the next lake and repeat. One of the interesting things about it is that the measurements of distances on the maps are done in rods, which are roughly the length of a canoe. And so what this project is doing is just simply doing a little bit of arithmetic to do some conversions from from rods into other units. And the basic idea of almost every programming project that we do is you take some input, you do something, in this case a little simple arithmetic, and then you print out your results. Okay, so basically three parts to it. Take some input, do some arithmetic, print out your results. And we're going to do this using Python, and we're going to write the program in Spider, and then when we're ready we submit it into this system called Mir, and that will run some tests on it, so you'll get some immediate feedback in terms of what your results are. Be careful that we specify what the output should look like, the values that you print, and you need to get those as we specify them, because the Mir testing is quite picky about that. So if we say you have to do it this way, it's got a period in there, then you better make sure it has a period in there. So that type of thing, the details matter. So we give you some specifications, and yeah, the details matter, because that's, details matter in programs. Just last week, there was a satellite that was lost because somebody put the coordinates in wrong, and these kinds of things happen. The details matter, so yes, right from the get-go, details matter. This particular one, and many of the ones that we do, you can figure this whole thing out with paper and pencil without even thinking about how it works with respect to programming. And you really want to start that way on this, because get the confidence down. Yes, I know how I can solve this problem. Hey, it's arithmetic. You could have done this arithmetic back in middle school or something when you're 12 years old, and so do it. Get the formulas right, and we actually encourage you on this stage, sort of the planning stage, before you get to the actual coding, to work on it with somebody else. When it comes time to actually doing the Python, the programming part, then we want you to do that on your own. But kind of the problem-solving stage of figuring out how you're going to do that, by all means, do it with somebody else. Work that out, but when you get to the Python, yes, we expect you to do that on your own. So let's take a look at this. We have a specification for every project, and we expect you to hand it in at a particular time. We say 11:59 because then it's clear, sometimes whether it's midnight or not. Projects are due on Mondays. If you are from a foreign country, take note of that, because when we hand things in on Mir, the times that it uses to display, it checks your computer to see what time zone your computer is set up as, and it will post the times that way. So these are due based upon Eastern Standard Time. If your computer's set on some other time, you're going to have to make an adjustment in your own head do that. So as I mentioned, this was inspired by canoe trips. Yep, there I am. In the Boundary Waters and up in Canada. I go every year, and the measurements are due in rods, and we will do some conversions based on that. So the idea here is, we go through some steps where what we're going to do is you're going to work on solving the problem. And then you are going to code it in Spider. And then you're going to submit it in Mirror. And now you can submit things as many times as you want. Strategy here, the program itself, it will take some input, do some calculations, and then it will print some output. What does that look like? Well, let's take a look at Spider, and I'll write some simple code. So let's take an input string, and what you do here is so we have this Python statement called input. It has a string, that's what's between the quotes. So we have and notice that's purple. All right, so that's that's a Python command. Then we have a string that's called, it's the things between quotes, and you can use single quotes or double quotes, but whatever you use at one end, you have to use it also at the other end. And then I have some kind of a name that string goes into. So I called it in string. So what this is going to do is this is going to prompt, ask you to enter something, and whatever you enter gets stored in there. I can actually run this simple one-line program. It's going to ask to save it. And I give it the name proj01.py. It's going to say there's already one there. That's okay. I'm going to replace it. Now I can actually run this, and notice what happens here is that we end up with the this enter something is what shows up here. All right. Now if I type something here, and nothing happened because, hey, we didn't do anything with the input values, and I actually can, so let's fix that. Let's print it, and I will save it. I will run it again, and it says input something, and it prints it. So notice the process here. we prompt. There it is, the prompt, and that stored a value in int string, and then I said print it, and so that is the printing of it. In fact, if we go up here and let's see if Variable Explorer, it's got a bunch of stuff in there, but notice that the at the bottom there we have this the name of the variable is int string, its type is a string, and its value is 2345. And in fact, if I wanted to down here, I can also do a print of the int string, and I can also do that. Notice there's a slight difference here, and that is that when I print the value, it doesn't show it with any quotes, but if I just say int string there, it shows the quotes, and that's a little bit different from if you print a string, it prints it without the quotes. That's a little bit confusing there. Now let's change this to say enter a number. Not that it matters, but if I have a number, let's convert it to a float. So you want to be careful in computing where the difference between some digits, which are strings, those are the things you type in, and an actual number. In fact, let's actually start with an int here. Let's make this into an int, and then I'm going to print and I will name it as an int, and I will print the int string, and then after that I will print the int. Alright, I'll save it, and it asks for a number, 2468. Let's take a look at what happened here. So we say enter a number, I can't type, and then we convert that to an integer, and we print the string, we print the integer, and notice that they look exactly the same. However, if I look back up here, the string is a string, the int is an int. And so I can, in terms of arithmetic, this makes a big difference. For example, if I take my int and I divide it by 2, I end up with 1, 2, 3, 4. Okay, that's what I expected it to get. But if I take the int string and I divide it by 2, I get an error, because what does it mean for me to take a bunch of characters and divide it by 2? It's you can't divide a string. You can divide a number, but not a string. So we care about that difference, and if I liked, I can I can do this as a float, and the naming doesn't matter. I could call these Fred, George, Mary, whatever. Things would still work the same way. Oh no, I still can't put my number in there. Now we can notice a difference. Notice a little difference here when I have the float. So I converted this into a float, and then I have string and float, and now when I print the string, I just print the string, but when I print the float, oh, it has a 0.0 on there. So you can actually see the difference. And now, all right, let's do a little bit of calculation. Let's say result equals 2 times my float that came in, and in addition to the float, let's print the result. And let's actually label it. Result is result. And now notice how this works. I'm printing two things, a string, which will be printed exactly, comma, the actual value. And while I'm at it, let me finally remember to take care of my typo there. We save it, we run it, and it says enter a number, and 124. And again, it does. There's a couple of things that happen here. This is kind of interesting. So one thing that happened is that as I was typing it, I actually put a space in there, and so my string has a space in front of it. My number doesn't. And then when I doubled my number, I got the 248. So we can again take a look at these. I got a bunch more things here, but I have my float. Notice the int still stays around. We'll talk about that later while it still stays around. But my string, notice it's got a little space there on the front, and then you can also see the result. If you're curious, you can say something like, I have my in string, it has that value. Notice you can see the space up there. What is its type? Oh, it's a string. But now we can, pretty much everything is here that you would do in your program, because guess what? You've already worked out the arithmetic. What happens? So we have some input. We do some arithmetic, and then we print some results. And that's that's what our project is about. And at this point, you would then open up Mirror, hand it in, and run the program. I'm not going to do that right now because I don't have any any information that's my program isn't doing anything like what your program is supposed to do. But hopefully, this gives you enough to get started. And good luck.